Hello, this is a lesson on describing characteristics of polynomials. So in this lesson, we're going to talk about increasing and decreasing of polynomials, as well as where f of x is greater than 0 and less than 0. We have already talked about increasing and decreasing functions when working with quadratics, so this is going to be very similar to that. And then something a little bit new is where f of x is greater than 0 and less than 0, and that's just simply for whenever f of x is greater than 0 is where it's above the x-axis, and where it is less than 0 is where it's below the x-axis. So in this instance, f of x would be greater than 0 and anything in green here, and then would be less than 0 anything in red here. And the only tricky thing about that is we do not include the point where it is equal to 0, right? Because there it is equal to 0, not greater than or less than. So in this case, we would not include the point -2, 3, or 5. And then again, increasing is just wherever that function is going up if you were to trace it with your pencil. And decreasing is wherever that function is dropping or going down if you were, again, tracing with your pencil. So we're going to look at a few examples of identifying those intervals. Okay, so if you feel like you have a good grasp on this, go ahead, pause the video, and then just check back in. But I'm going to run through this first problem here. So an interval of increase, if I take my pencil and I were to trace this graph, remember I have to start most to the left, work left to right. It would be increasing here. So I know I'm going to be increasing from negative infinity to, that would be -1, right? Then we start to drop, which would be an interval of decrease, right? So it's going to decrease from -1 to 1. Now, this might be something new, is that we have two intervals of increasing, right? Because now my pencil starts to go back up from the interval of 1 to infinity. Okay, so we have two intervals of increase. And the new concept is that we have to connect those with what's called a union symbol, or it's really simply just a U. Okay, and we only had that one interval of decrease, so we're good to go there. Now we take a look at where is f of x greater than 0. That's going to be anything above the x-axis, right? So the only spot where f of x is above the x-axis would be right here, right? So that's at the value 2 and then to infinity, because that's going to continue going up forever. Okay, now where is f of x below the x-axis? So that's all of this, right? All of where it's below the x-axis. Now remember, I said we cannot include where it touches the x-axis, which would be where it's equal to 0. So we're not going to include that point -1. So here we're going to have two intervals, negative infinity, right? It's going to go down forever, negative infinity to -1. And then I said we cannot include that point, so we need to start a new interval, -1 to 2. Okay, and just like we did here, we're going to connect those with that union symbol. Okay, and they're always going to be parentheses because we're not including those points where it's equal to 0, not including, so we use parentheses in that point. Okay, I encourage everyone to pause the video now and try the intervals of increase, decrease, where f of x is greater than and less than 0 with the function shown here. All right, so I'm going to again take my pencil and trace starting left, most to the left, and I'm increasing negative infinity to 0. Then, right, my pencil drops and I'm going down from 0 to 2. Then my pencil starts to go up again at 2 to infinity. Now remember, we need to connect those with the union symbol. All right, now where is f of x greater than 0? Anywhere where f of x is above the x-axis, so that's all of this, which is, remember, we're not including this point, so we're going to have a broken interval here, or two intervals, which would be -1 to 2, and 2 to infinity, again connecting those with that union symbol. Okay, now where is f of x less than 0? Anywhere below the x-axis, right? That's going to be that interval, which is -infinity to -1. Okay, again, remember we need to put that smallest number first, just like we did with domain and range, and when we were looking at increasing and decreasing of quadratic functions, that smallest value has to go first, right? Working smallest to biggest. All right, now here's an example of where they're describing a function. Describing those intervals of increasing and decreasing, and where f of x is greater than or less than 0, and we need to come up with the graph. Okay, so this is a little bit more tricky. So f is increasing when from -2 to 3, right? So increasing, I'm going to draw a line up. So from -2 to 3, and we don't know. It might be something like that, right? -2 to 3, increasing. Now, f is decreasing wherever x is less than -2. So everything to the left of -2 is going to be decreasing. All right, that -2, we have that turning point. And wherever x is greater than 3, so from 3 to infinity, it's going to be decreasing. All right, now we need to figure out where is f of x greater than 0 and less than 0. So we go ahead and take a look here. It says greater than 0 when x is less than -4. Okay, so I take a look. Well, I just so happened to draw a spot on. -4, it needs to be above the x-axis. So that was actually honestly pretty lucky of me. But if it wasn't there, I would just simply erase that line and then start at -4. And I know it needs to be above the x-axis there. And then from -4 below the x-axis in between there. Okay, and then from 1 to 5, it needs to be above the x-axis, okay? So here's a good example. I was a little bit off. So remember we have that turning point at 3, but from 1 to 5, it's above the x-axis, okay? So I'm going to stop there because we have a turning point. I'm just going to turn it red so we can understand or keep following. And then to 5, right? And then at 5, it drops below. And then I can reconnect these lines here. Okay. That got kind of ugly, but you can see at 1 and at 5, it's above the x-axis there. And then from negative infinity to 4. Now we can double check where's f of x less than 0. So where's f of x below the x-axis from -4 to 1. So -4 to 1, it's below, we're good there. And then whenever x is greater than 5. So we're good there. That's a rough sketch of our graph. Now again, go ahead, pause the video and try this one on your own and then check back in. So I'm going to start with f is increasing from -2 to 0. So -2 to 0. Then whenever x is greater than 2, it's going to be increasing. Okay? Now f is decreasing. X is less than -2. So anything less than -2, it's decreasing, right? -2, we have that turning point. And from 0 to 2, so we have this missing interval from 0 to 2, it's decreasing there. And try and make our turning points a curve if we can. Okay, now take a look. Where is f of x greater than 0? Whenever x is less than 3, -3, excuse me. So x less than -3. So here is where it should be above the x-axis. And then So I'm going to erase that old line. Okay, so at -3, it's greater than, I'm sorry, when x is less than -3, it turns greater than 0. And then from -1 to 1, so I was actually pretty close here. -1 and then to 1. All right, so then I can just reconnect those lines. And okay, I'm gonna have to redraw that. That's okay. All right, then we can just go ahead and double check. F of x is less than 0 from -3 to -1. So we look -3 to -1. It's less than. We're good to go there. And from 1 to 3. Oh, I forgot to do this. F of x is greater than 0 whenever x is greater than 3. So at 3, I need to redraw that line. So that was a good check because I see I missed one. Okay. So now from 1 to 3, it's less than. 1 to 3, less than or below the x-axis. And that's all we have for today. If you have any questions, as always, please reach out with those. And then today you should be completing your chapter 4.1 through 4.3 review for the quiz that is tomorrow. Have a great day.